Welcome to the class. Dear students, today we are going to discuss dehydrohalogenation of alkyl halides. Dehydrohalogenation of alkyl halides. So, dehydrohalogenation of alkyl halide, it is elimination reaction and it is shown by alkyl halides. And elimination reactions, it can proceed through any of the two mechanisms. Either it can proceed through the E1 mechanism or it can proceed through E2 mechanism. So dehydrohalogenation of alkyl halides are elimination reaction where atoms or groups are eliminated from the substrate, and this reaction is shown by alkyl halide, and there are two routes, there are two ways that the reaction can proceed. The first mechanism is the E1 mechanism, the second is E2 mechanism. Dear students, in this video we are going to discuss what are ER reactions by looking at the reaction itself, and then first we will go through E2 mechanism and then we will look into the E1 mechanism. So let us start. Elimination reaction. To understand elimination reaction, consider the reaction of an alkyl halide with a base. So I am going to write an alkyl halide, chloropropane. Okay. Chloropropane, I am writing it like this. So this is chloropropane. I am going to react it with a base OH minus. What would be the outcome of the reaction? Before saying this, let me remind you that OH minus has actually two options. Option 1, OH minus can act as nucleophile. It can act as a nucleophile. So if it acts as a nucleophile, what it will do, it would attack this carbon atom which is having chlorine, and it would substitute chlorine, and in that case the product that will be formed is N-propyl alcohol. So that is nucleophilic substitution reaction. That would be nucleophilic substitution reaction, and that nucleophilic substitution reaction can proceed through any of the two routes. Either it can proceed through the SN1 route or it can proceed through SN2 route. To know more about SN1 and SN2 routes, kindly refer my earlier video titled SN1 reaction unimolecular nucleophilic substitution reaction and SN2 reaction bimolecular nucleophilic substitution reaction. If you look at these videos, you will much better understand what is nucleophilic substitution reaction, and you will understand how OH minus reacts as a nucleophile. Now there is second option, which is what we are going to discuss in this video. In the second option, OH minus acts as base, which has a pair of electron. Okay, here it is having a pair of electron, so it may act as a base. So acting as a base, what does the base does? Yes, it takes a proton and it becomes neutral. So here the OH minus may knock out a proton, okay, from the carbon atoms, from any of the carbon atom, and it may become neutral, okay, become H2O. So here what happens is, in elimination reaction or in dehydrohalogenation of alkyl halide, what happens is, look at the substrate molecule. There are three R groups here. All are pumping its electron towards chlorine, and chlorine itself is electron withdrawing in nature. It's highly electronegative, so it also withdraws electron and they are pumping. Because of this molecule is a very highly polar molecule, and a big dipole exists between them, this side being negative and this side being positive. So already there is a big polar gap between the two ends of a molecule. In addition, to add fuel to the fire, OH minus, it knocks out a proton from this side. Okay, now when it knocks out a proton from this side, this carbon is left with a pair of electron. This electron is also getting pumped now to chlorine. The chlorine also at the same time, this can happen simultaneously. At the same time, chlorine also goes. Okay, chlorine minus also goes, and this electron pair, it would come and jump here. So the product, this electron pair would come and jump here. So the product of this reaction will be prop-1ene or 1-propene, and H2O goes and Cl minus is eliminated from the reaction. Dear students, what we have seen here is two atoms are getting eliminated from the reaction. So reactions in which two or more atoms gets eliminated are called as elimination reaction. To talk about this reaction specifically, what happens here is a halogen atom is abstracted from alpha carbon atom, right? And a proton is abstracted from beta carbon atom. So this reaction is alpha beta elimination reaction, or simply you can say it as 1-2 elimination reaction. 1-2 elimination reaction. Dear students, this is what elimination reaction or dehydrohalogenation of alkyl halide is about. How it has eliminated, how the groups have been eliminated. We have seen a H from beta carbon atom and a Cl or X atom from alpha carbon atom. Now let us discuss specifically about E2 reaction. E2 reaction. Okay, the E2 means, the full form of E2 is bimolecular elimination reaction. Bimolecular elimination reaction. You may write full. Now the use of the word bimolecular means that it is dependent on two molecules. Which two molecules? The molecules that participate in the reaction. The two molecules that participate in this reaction are alkyl halide and base, OH minus. These are the two molecules that participate in the reaction. Now when I say that the reaction is dependent on two molecules, then what does it mean? What would be the probable mechanism? The probable mechanism would be an encounter between these two molecules. Okay, when I say that the reaction depends on two molecules, okay, equally, then what I mean to say is that there is an encounter between the two molecule, or there is a collision between the two molecule. So if you are increasing this concentration, the concentration of the substrate, or if you are increasing the concentration of the base, the chances of such collision or the chances of such encounter increases, and that would increase the rate of the reaction. Therefore, in E2 reaction, the rate depends upon concentration of substrate and concentration of the base, because a collision is involved. If you are increasing this concentration, or if you are increasing the concentration of the base, the chances of collision is increasing, and that would obviously increase the rate of the reaction. So that is a general introduction on the E2 reaction. To understand better what is E2 reaction, let me draw the reaction itself. I am going to draw the chloropropane, which I have drawn earlier to explain elimination reaction, but this time I am going to draw a little differently. H3C, CHH, CH2, Cl. OH minus is the base. Now OH minus has chosen itself for option number 2, that is act as a base and knock out the proton. There may be several reasons why OH minus might have chosen option number 2. One of the reason of this is that OH minus is sterically very big, okay, or base is sterically very big, and being very big, it cannot attack this carbon atom because of steric hindrance provided by the nearby groups. Therefore, it may act as a base and knock out the proton. So that may be the reason. Anyway, OH minus and this substrate, already you know there is 3R group and 3R groups are pumping its electron, and Cl minus is electron withdrawing, so it also withdraws. A polarity exists between them. To add fuel to the fire, OH minus knocks out H, right, and this pair of electron is left here, and Cl also now goes. There was already tension here, and what would result is S3C CH double bond CH2 H2O Cl minus. What I want to say here is E2 reaction, the abstraction of a proton, and the elimination of chlorine from alpha carbon atom and abstraction of proton from beta carbon atom takes place simultaneously. There are no intermediates involved. So that is the E2 reaction. Dear students, I hope you understood E2 reaction. Let us now come for E1 reaction. E1 reaction. What is E1 reaction? The full form of E1, unimolecular elimination reaction. You can write full elimination reaction. What do you mean by unimolecular? When I say unimolecular, what I mean to say is that it is dependent on only one molecule, that is the substrate molecule. The reaction depends only on the substrate molecule. That actually means it depends on the chemical character of the substrate molecule. The chemical character to participate in the reaction. How would it participate in the reaction? By becoming an ion. Okay, so only those alkyl halides that can become stable carbocations, they can show E1 reaction. Okay, for your information, if you have seen my earlier video of SN1 and SN2, we know that tertiary alkyl halide, they give a very stable tertiary carbocation. The tertiary carbocation that is formed is very stable there. So ionization is very favorable for tertiary alkyl halide. So that kind of substrates, they would only undergo which kind of reaction? E1 reaction. That is, alkyl halides where ionization is favorable, they will undergo E1 reaction. That is tertiary alkyl halide, no doubt. Okay. Now let us, to understand what is E1 reaction, let us now go to the reaction itself, to the mechanism. There are two steps in the mechanism. Step number 1, ionization of the substrate. Ionization of substrate. So we are going to draw a tertiary alkyl halide. So this is our tertiary alkyl halide. I draw 3CH3 tertiary butyl chloride. I am drawing. Okay. What would go? It is a very highly polar molecule. 3CH3, they pump their electron. The carbon here also pump its electron to chlorine. The chlorine is just opposite in nature, very electronegative. It also withdraws electron. So this side is always negative, this side is always positive. They are bound to dissociate, no doubt. And what you will get? You will get something like this. A carbocation is formed. If you have seen the earlier video of SN1 reaction, you know that the carbocation formed is a triagonal planar carbocation. Because 3 groups, they will go to the farthest position available. So that would lead to a triagonal planar carbocation. So this is the first step in E1 reaction. Step number 2. Attack of base. Step 2, attack of base. Let us see the carbocation. This is the carbocation now. The base, it may be sterically so bulky that even after the elimination of Cl minus, the base is not able to enter here and attack the positively charged carbon atom, it may be so much bulky. In such case, the OH minus may knock out the proton here, and this pair of electron, it would come here. So now what we get is this is 2-methyl 1-propene, 2-methyl 1-propene, 2-methyl 1-propene. Dear students, this wraps up our our E1 reaction also. In E1 reaction, we have seen that the reaction consists of two steps. The first step is ionization of the substrate. So ionization is inevitable. Those who form stable ions, stable carbocations, only those alkyl halides will show E1 reaction. Stable carbocation is only formed by tertiary alkyl halide. So they will definitely show E1 reaction, and there are two steps we have seen. This is the step 2 where the base attacks OH minus. Okay, the base OH minus attacks the carbocation. In E2 reaction, we have seen that it occurs in single step. The expulsion of halide and the expulsion of proton from alpha and beta carbon atoms, it occurs simultaneously. Dear students, that ends up E1 and E2 reaction. In part 2 of this video, we will see the orientation and reactivity of E1 and E2 reactions. If you have understood and liked the class, please do not forget to subscribe the channel. Thank you very much.